Welcome to the Smart QA Musings. In today's webcast, the focus is on discussing what is the role of structure, not content, in engineering smart assurance. So what I will do is to take a look at other engineering disciplines and see how structure is very key to their success, to good engineering, and then kind of very quickly graduate into testing and assurance in software, and then look at what do we mean by structure and what are elements that might be of interest and possibly add value to assuring smartly. So without much ado, let us take a look. Maybe have a couple of slides which will focus on what is the role of structure in other engineering disciplines. So you might be wondering, what do we mean by structure? I guess this will answer you. So when you take, for example, civil engineering, some of the key elements that constitute the idea of a structure, which ultimately holds these major big civil engineering artifacts together, could be like foundation, could be like walls, columns, reinforced concrete, which is rebar, trusses, beams, drainage, etc. All these are elements. For example, a foundation, what it does is basically transfer the load of the building to the ground and prevents settlement. What do beams and columns provide? They provide support to horizontal loads and distribute weight to the columns, and the columns provide the vertical support and transfer load to the foundation. So you see, all these are structural elements which are responsible for load bearing, safety, stability, strength, durability, and so on. And that's really what we talked about here. So without a good structural engineering, a lot of civil engineering would not work. And I'm sure we all understand the role of a structural engineer in some of these disciplines which are not software, be it in the context of civil, be it in the context of mechanical, and so on and so forth, right? So I guess there is a role, and there is a discipline which is specialized into the science of forces in structural engineering. So some of the elements, that's what is listed here. Let's jump down and look at what are elements in the context of mechanical engineering. So similarly, there are different elements whose role is very paramount in mechanical engineering. Could be gears, linkages, frame, chassis, suspension, damping, thermal management, control systems, and so on, right? And they have a significant bearing on foundation, stability, energy transfer, smooth motion, shock absorption, heat control, automation and precision, and so on. And what are their outcomes? Their outcomes are about ensuring strength, again, similar to what we saw, strength, stability, efficiency, smooth motion, which is great experience, durability, and so on and so forth. And ultimately, you look at it from a longevity standpoint of minimizing wear, failure, long-lasting performance, and so on. So the point I'm trying to drill forward is the fact that structure is paramount to good engineering. And therefore, I'm trying to look at it. What does structure mean in the context of our engineering? From the context of software engineering, test engineering. So we'll kind of move into a bit of a software design and then move into software testing as we go forward. So when you take design, when you take the act of construction, what are some of the key elements that we see which can be deemed and called as the role of the structural elements? I'm sure we all have studied or seen a subject or very well aware of the subject of data structures. So what does it tell you? Hey, when you want to have data, there are elemental structures which we would have seen as queues and links and stacks and so on and so forth, trees and so on, which are basically data structures. So they provide a mechanism to say, hey, these are very elemental data structures and they are used in certain situations. They have a certain advantage and they provide certain value. Similarly, you will go higher and you will look at structure in terms of how we construct, maybe layered design architecture, the idea of modularity in terms of pieces that are independent. Then we look at it from a pattern perspective, which are more architectural elements. Then we look at security as a framework, error handling as a framework, and so on. So all these, if you will, could be deemed as, in some sense, the structure that defines the design aspect and therefore valuable for architecting and building good systems. For example, architecture pattern may be helping you define a structure to ensure scalability. Modularity may be helping you to break into components and promotes reuse. Data structure is about organizing data efficiently and primarily responsible for high performance. APIs, interfaces, they standardize communication, enables extensibility of a system, and so on and so forth, right? And therefore, at the end of the day, a good structure makes software reliable, scalable, efficient, adaptable, and so on and so forth. So it's not just the content of the code or the content in terms of material, but it is also the fundamental overarching structure that has a significant bearing in all these engineering. So now, what does structure mean possibly in quality engineering? And then we'll take it into a little bit of a details. So possibly, an idea of a good structure in quality engineering, the notion of assurance, hopefully ensures that we have a good, efficient testing method, approach, whatever. Hopefully it's more accurate and effective, it is scalable, maybe helps us to trace so that we know we have covered everything, helps us to be maintainable if it's automated and stuff. And what we ultimately want to do is we want to prevent, we want to optimize, maybe automation, we want to minimize debugging, we want to foster a sense of continuous improvement. So what we're trying to do is to say, look, what is the role of, what are structures in software test engineering per se, which could help these various attributes to be met. And therefore, let's take a few minutes from now to look at that. What is the role of structure and what are possibly some structural elements in quality engineering across the typical life cycle of testing, which could be deemed as understanding and setting up a baseline, putting together a strategy, approach, and a plan, coming up with some initial design, converting that into scripts and automation and providing something as a scaffolding to test, the act of evaluation, then subsequently the act of reporting, and finally analysis, and the story repeats all over again, right? We might iterate. So all I'm going to do is to kind of take each one of them and probably muse about some of the ideas that come to my mind and some of the things that I hold very dearly in each one of these, and I pay attention to these structures when I attempt to validate. So when I look at the notion of baseline, which is primarily about before I kind of test, I want to be sure what is it I'm testing and what is it I'm testing in for. So I really would obviously want to understand a little more deeply, far more broadly, get a larger context, look for multiple angles. And so what I'm really doing is this idea of a structure to me is a map, right? So I'm kind of saying, maybe if I had an idea of a structural element as a map, then maybe I could use it to understand. And so one of the instantiation of a map could be an unstructured version, a mind map. So where I'm probably connecting various pieces and therefore formulating or synthesizing a good or better understanding of what are various pieces that constitute the system under test, how are they interconnected, who uses them, where, what is new, what is old, what could impact, and therefore start getting a better understanding and seemingly better clarity and so on. So that is at a higher level. If I want to sharpen that and then I want to set out a baseline, which is like say, okay, so let me set up a bit of an objective and a purpose of what I want to accomplish. Then maybe I need to set up some kind of a map which says, okay, this is a map of entities under test. Here are features, here are screens, here are functions, here are end user requirements, here are end-to-end flows. So all I want to kind of look at it and say, I have got so many end user flows, so many business requirements, and this is how they are composed of the various features, and this ultimately uses these structural elements. So I want to look at it as a bit of a composition of the various entities and therefore put out a little bit of a map. But there are multiple maps. One may be related to the entities under test. Another may be relationship in terms of who uses what, which is basically a map of persona or an actor to a use case, so to speak. The other map could be a scope, which is like saying, here is an element to test, and I'm really wanting to understand what should I test for. I mean, obviously we'll say functionality, but in addition to functionality, am I going to be sensitive to certain non-functional attributes? And if so, what is it that I'm going to validate? So if I say it needs to be performant, then I need to be able to clearly state as to what is the testable aspect of performance, right? So that's kind of a scope map. And we all know that we are not always building brand new software. We already have an existing one. We are enhancing some, we are adding some, we are fixing some. So there is obviously a notion of interaction map, who affects what, who may affect what, right? And finally, in current world, possibly the environments are very many, so we construct a map. So the idea here is maybe map as an element or a structural element could possibly be useful in helping me clarify what I need to do and hopefully have a better idea to go forward into the next aspect, which is about a strategy. So, which means I have got certain idea what I started off with. Okay, this is my scope. This is what I need to test, and this is what I need to test for, and so on and so forth. So quite obviously the natural step is, so what is the approach? Can I have a structure which I can expand maybe into a approach document or a strategy document or a test plan document, whatever the content, so to speak, right? But to me, I think of it as a Cartesian set. So to me, the structural element is a Cartesian set. So what do I mean by that? I simply mean that there are various elements which are all individual sets, which if I do a product, a Cartesian product, which is like say, what am I testing? That is features and requirements and flows. What am I testing for? It could be functionality, attributes and types or whatever. And where am I testing it? What are the various environments that I should be sensitive? How am I trying to test it? It could be inspect, it could be check, it could be test, it could be human, it could be machine. And of course, sometimes it could be testability itself, which means you are not adding into the spec. So these various elements of what to test and test for what and where to test and how to test, to me, are elements of various sets. And these sets contain the features, the requirements, flows, and so on. If I do a Cartesian product, then that to me is the basis for a strategy, which I can expand upon, if you will. But the elemental structure to me is a Cartesian product. Going further down and say, okay, now that I have an approach, I need to get some initial ideas in terms of scenarios and cases, which I will refine, strengthen, enhance during the act. And so how do I view? What are structures that could be of use to me? What are elements, that structural elements that I could use? Maybe I could think in terms of maybe levels. So what are levels? Maybe I look in terms of, hey, I've got to find different classes of bugs, different types of bugs. So if I view them in level 1 bug and level 2 bug and level 3 as classifications of different types of bugs, and if there is a well-formed order, then I could be optimal. Maybe I could be clear in my role, somebody else's role, and be optimal. So I could say, the first few levels are all dev-oriented, next of them is QA-oriented, then last levels are customer-oriented and stuff like that, right? So that's the idea of a level. So the whole idea here is we layer the test cases or layer the scenarios as we get the first step, so that we can be more clearer, complete, and efficient. The second kind of stuff is we all understand, grouping them in the notion of types. That is, you don't put all the buckets of all the test cases or scenarios into a bucket. You might group them into different types of tests. So it's like seemingly different buckets. The third kind of idea is the structural element is views. How many views am I looking at? So am I looking at it from feature and function from a system? Am I looking at it from different users? Am I looking at it from different attributes? Am I looking at it from integration with external systems. So what are the different viewpoints that I ultimately come into picture, and therefore ensure that I do have scenarios and test cases that hopefully cover multiplicity of views. So the third kind of a structure that I would probably have in my mind is multiplicity of views, right? And the last one is the constant worry of how do I know that I'm doing a good job? How do I know I will be able to do a good job? So so the analogy and the structural element that I can think of visually is like a net, where fishes seem to be like bugs, as the picture kind of says. And so I'm really looking at what kind of fish, what kind of net, how deep, how broad, how small is the hole. And therefore, I'm looking at it from the notion of granularity of issues to be caught, and therefore the idea of is the net broad, deep, porous, etc. Right? And these are some of the ideas that have been having as a part of a methodology, and that's why they start up there. So to me, the idea of level, type, and views and net and stuff like that are some kind of structural elements, so that I can visualize better, think better, and then of course create hopefully valuable and meaningful content for me to continue on. So when it comes to possible automation, we all write up scripts, we all put in frameworks to test, we all have certain test scaffolding to build. So what do we want? We all know it's about good principles of development here. So we are not talking anything fancy up here. We are really talking about the fact that scripting and automation should obviously follow and stem from good principles of development. So what do we mean? We talk about fundamental ideas of cohesion and coupling, which are very fundamental to good design and code. And the third one is the categories of scripts and categories itself. So I can think of it in terms of three structural elements. One I call as category, which is like saying, if I have to look at scripts, is there a way by which I can partition them into different categories, so that it is simple, easy to maintain, and hopefully easy to tweak and adjust as the software evolves. Otherwise, I would end up having a large body of code. Fairly recently, in one of the customers, I stumbled upon a piece of code which they said, hey, this script is a few thousand lines long. And I was kind of shocked, because it's a pretty long piece of code. And the reason why that turned out to be long is the fact that they were looking for all kinds of bugs in one script. Some of the bugs were related to the boundaries. Some of the bug, because it was a UI, it was also related to the layouts and colors and mandatoriness. Some of them were related to acceptance of values and processing of these values, based functionality. Some of them were related to the fact I wanted to be sure that the data is transferred to some other systems, and therefore it is held in some databases and files. So what they were doing is they were trying to look at a variety of different bugs in one script, which is brilliant as far as the human is concerned, but it makes the script very complicated. I personally would have wished that if I had a smaller script to only look for boundaries, and had only a smaller script to look for colors and layouts and UI and stuff like that. And then we could have made a more bigger script by putting them together like a function and a combination of functions. So the idea of categorization and grouping is basically to ensure that hopefully I have easy, modular, small pieces of stuff. And if I could have certain meaningful cohesion, which is what some of us do, we would end up having leverageable common code. So the idea here is, if there are certain common pieces of code that could be used by different test folks to build their scripts, then maybe that's a common library, and therefore the idea of cohesion. And finally, the coupling. What do we mean by coupling here? We mean that I have a bunch of scripts. I would like to run as many scripts in one long run, so that I don't have to pause, right? I don't have to stop and restart. So how do I devise such? So the idea of cohesion, coupling, and categories, which are certain elements of structure, to me are probably useful in how I look at smarter notions of automation. The idea of evaluation is an activity. So we are looking at elements which are more activity oriented rather than content oriented. So to me, the idea here is, can I do it in short, bursty, mindful sessions, right? Therefore, I call it as immersive in nature. right? So session to me is an elemental structure where I say, look, I would love to kind of block myself out, be focused, think about it, be totally involved in this job, maybe for an hour or maybe for an hour and a half, because I probably cannot maintain my mindfulness or my focus for beyond a certain time. And therefore, I might be motivated to look at short and rapid immersive sessions of test, and therefore the structural element is an idea of a session. And I do know that I may not be able to appreciate or understand everything, because as I go into the job of evaluation, I discover, I learn, I may have to backtrack, and therefore the idea of iterative notion, which I think we all practice today, is possibly a structural element as far as evaluation is concerned, whose primary focus, as we all know, is do, learn, improvise, and repeat this as much. And you repeat as long as you have time. So the session and iteration are more often structural elements from the idea of activity, right? Not content. Whereas when it comes to the last two phases of the cycle in terms of report and analyze, so if I have to publish a report, maybe it's simple as a defect report or an execution, any report which kind of talks about what has been done, what has been accomplished, I think the structural element that I keep in mind is from the reader's perspective, from the person who's consuming, is first the summary, then the detail. First the outcomes, then the action. So what does it mean? It simply means I don't want to overwhelm somebody with a large report, which is a rambling one. Rather, I would like to put like an executive summary or a tabular chart or whatever, which I'm sure we are all aware of. And of course, then expand upon it to provide meat to the content so that somebody can take meaningful action. So the elemental way I look at about it is summary first, detail next, right? And whenever we are publishing a report which demands some action, first you state what is the outcome it was accomplished, intended, reached, and then what are suggested actions or actions done, right? Rather than putting the action first and the outcome later. So it kind of sets the tone. This is what I want to do. This is therefore what are the various actions. This is what I want to accomplish, and these are what you should be doing. That in the context of reports. Slightly two different kinds of reports. One is more like informational, one is possibly more action oriented, but both are again in this case the structure of the content as in terms of a report. And finally, when we come to the last stage of saying, okay, I am doing some analysis, which is again in some sense an action. I am trying to learn, I'm trying to do maybe a root cause analysis, whatever. The idea here is the pattern or the structural element that I'm trying to think in terms of is first diagnose deeply and then solve, right? So do a little bit of a deep analytics, get to know what the problem is, do a better diagnostic first, then come up with a solution. And the reason for me to talk about it is specifically when I've seen in certain organizations where we kind of jump into the act of solving. We immediately start synthesizing solutions when we should be doing a little bit of a diagnostic and maybe then figure out a solution. So the elemental structure to me is diagnose, then solve. And last one, very similar to what the report was, is first set up a goal and then figure out the actions. Because, the action of solving or action of doing is something that excites most of us because we get very happy doing things because it seems to be that I am not wasting time. I'm active. But so the lure of activity is always much more intense in most of us, which is very, very understandable. And it is sometimes boring to say, let's sit back and realize what is the problem, what was the intended goal, and so on. And that is what this particular thing as possibly elements is trying to suggest and say, hey, maybe the before we look at the active analysis, look at it from the structural elements of diagnose, solve, vis-a-vis, and goal action, so to speak, right? So what does ultimately a good structure really accomplish? It accomplishes or enables clarity. And to me, clarity is probably a very important thing when it comes to any job. In our case, it is assurance, and we are wanting to be smarter assurance. So the idea that that it is very important to be clear is, I think, paramount, and a good structural piece helps us to see them. So first is see clearly, then you augment whatever you want to do with good practices, good processes, and great tools. Right? And that's how I view the idea of structure. So structural is not just about the scaffolding inside. It has a big purpose, and the biggest purpose to me is it helps me attain the notion of clarity, right? And that's why the picture seems to be that that Buddha pose sitting up there kind of a story, that I'm able to visualize, I'm able to see, I'm able to really appreciate what it is, right? And going back and revisiting where we started off from, ultimately summarizing, if you will, a good structure in the context of quality engineering is basically how I arrange my activities, how I organize my test assets, and how I depict the outputs. And the notion of the role of structure is in the context of arrangement, organization, and depiction. And hopefully all of them helps me to see better, and therefore see a better purpose, or more than anything else, help me highlight that I am not able to see better, and therefore hopefully help me find an appropriate solution. So that, in a sense, is what I wanted to share with you as as certain interesting thoughts that I had on role of structure. I'm a very strong believer in the notion of structure in anything, because it's about seeing and visualizing in the mind's eye. So thank you so much.